This video I am going to find the deflection by the double integration method. What is deflection? Deflection is small displacement of structure due to applied load. It is represented by V or delta. For double integration method or direct integration method, we should know the following. EIV double dash is equal to moment equation. We take as a name suggests, we take the two integrations in this method to find the slope and deflection. Here are some boundary conditions. We should remember this. For the fixed path, deflection is equal to 0 and slope is equal to 0. Whereas for the pin and the roller, deflection is equal to 0 at the spot. There is no deflection at the spot. We will do an example to elaborate this method to find out the deflection. Here is method. Determine the slope and deflection at the points B of the cantilever beam. We have to find the deflection and slope at this point B. So first I will calculate the reactions. So for calculating the reactions, I will draw free body diagram here. This is my point A. This is reaction AX. Here AY. This is fixed path. There will also be a moment which is MA. Here force is applied 67 kilonewton downward. I will take the summation Fx is equal to 0, which will give me Ax is equal to 0 as there is no other horizontal force acting on the beam. Then I will take summation Fy is equal to 0, Ay upward positive minus 67 downward. It will give me Ay is equal to 67 kilonewton upward. Now for calculating the moment at A will be equal to 67 multiplied by this distance, which is 6.5. This gives me moment at A is 435.5 kilo Newton meter, which is counterclockwise, as this force is rotating the beam in the clockwise direction. So for the beam to remain in equilibrium, it will produce counterclockwise moment at A. So as in double integration method, I have said that EIV dash is equal to moment equation. So I will EIV dash is equal to V double dash is equal to moment equation. So I will make the moment equation. I will cut the section from here at the distance x from point A. Here was my reaction 67 kilonewton upward. Here was my moment 435.5 kilonewton counterclockwise. So my moment equation will be EI V double dash is equal to, this will produce Hog, so it is negative 435.5 kilonewton. This 67 will produce sag in the beam. This is sag and this is Hog in the beam. So it will produce hole in the beam. It will produce hole in the beam, therefore it will be 67 into x. As the name says, we have to take two integration, double integration method. So I will take first integration. This will give me EI V dash, where V dash is slope, is equal to minus 435.5 x plus 67 x square over 2 plus constant of integration. Then I will take once again one more integration, which will give me deflection. Equation becomes minus 435.5 over 2 x square plus 67 x cube by 3 by 2 6 x cube plus c1x plus c2. Let's say this is equation 1 and this is 2. We have to find this constant of integrations by using the boundary conditions. So we'll use a boundary condition. As for the fixed pole, deflection is 0 and theta is equal to 0. We will put these conditions in these two equations and we will find the C1. Slope, that is V dash, is 0 at x is equal to 0. So putting this in this equation, V0, 0, C1 is, this give me C1 is equal to 0. Now deflection, that is V is 0 at x is equal to 0, that is at fixed pole at x is equal to 0. Deflection equation, this equation gives me c is equal to 0. Now our deflection and slope equation will become c1 was 0, c1 0, c2 is also 0. So this is our slope equation and this is our deflection equation. Now putting given E was 200 gigapascal and I was given in our problem 315 multiplied 10 is power 6 millimeter 4. This will give me, in putting these values in these two equations, slope equation and deflection equation, put x is equal to 6.5 meter as B point is 6.5 meter from the left. This will give me slope at B is equal to minus 0.0224 radian, which means that negative sign indicates that my slope or angle is clockwise, whereas for deflection, put x is equal to 6.5 meter in equation 2, equation 1. This will give me slope at B is equal to minus 97.4 millimeter, which shows that my deflection is downward. Remember these conventions. Positive deflection means that deflection is upward, whereas negative deflection means that deflection is in downward direction. Please subscribe my channel if you like this video.